We are the Security Advisory Ingestion and Notification System project, and we'll start off by doing some quick introduction.
Hi everyone, I'm Ananya. I'm a rising junior majoring in CS and finance.
I'm William, and I'm a rising sophomore and majoring in CS.
Ryan, I'm a rising junior majoring in electrical engineering and statistics.
I'm Kelly, I'm a rising sophomore and I'm majoring in computer science and finance.
And I'm Catherine, I'm a rising sophomore majoring in computer science and poly science.
I'm going to start us off by talking about the terminology that I'll be using throughout this presentation. We'll start with CVE, which stands for Common Vulnerabilities and Exposures. It's a list of publicly disclosed security threats. CVEs help IT professionals coordinate their efforts to prioritize and address these security threats to make computer systems more secure. One of the factors that is a part of the CVE description is the CVSS score, which is a score on the scale of 1 to 10, 10 being the highest, that tells us about the severity of a CVE. Another score that is relevant to understanding our project is the EPSS score, which stands for Exploit Prediction Scoring System, which tells us about the probability of a threat occurring in the wild. Now I'll be passing it to William to get us started with what our project is all about.
Currently, the IT security staff at Duke is manually collecting advisory data and vendor announcements from various sources to maintain software security. Not only is this task very time-consuming and very tedious, as many vendors have their own advisory feed that the staff has to keep track of, but it also increases the risk of delayed responses to critical vulnerabilities. Here's just an example of just one of many advisory pages that the IT security staff has to keep track of. And as you all can imagine, keeping track of the countless vendors that Duke community engages with will become quite cumbersome. To address this problem, we are developing a unified dashboard that users can subscribe to that will allow users to receive notifications and access security advisor information. Our application automatically collects and displays relevant security information from vendors that the Duke community engages with, which will reduce the workload for IT professionals to respond to security advisories and allow the Duke community as a whole to be up to date with security issues. And now I will be going over the architecture of our application. The backend is a Rails API application that periodically sends out API requests to public databases such as CVE Details, which is an open source database of vulnerabilities that we found, and a CISA Kev catalog, which is a catalog of known exploited vulnerabilities that is organized by the government cybersecurity agency. This backend stores all of these vulnerability and advisory information into our database, which is structured into two main relational tables, vendors and CVEs. Each CVE entry is associated with a specific vendor, establishing a relationship where a vendor can have multiple CVEs. This structure allows users to select specific vendors that they want to keep track of and view relevant information based off of their selections. Our product also enables users to manually update their dashboards by fetching the latest information from these public databases so that they will always have the most current data. The front end of our system is built with React, communicating with the backend through custom-defined API endpoints. This architecture offers several benefits. The first of which is seamless data retrieval, as our architecture ensures efficient real-time communication between the front end and backend. The second of which is enhanced user experience, as the React framework allows us to develop a responsive and interactive user interface. And lastly, our modular architecture, where the front end and back end are two separate applications that run independently, makes it a lot easier to scale the application and incorporate future enhancements. Now I'll hand it off to Brian to introduce the UI of our application.
Here's a quick overview of our homepage, and in the following slides, I'll talk about each component. On the homepage, there is a bar graph as well as a dot plot, and the bar graph is showing the frequency of each CVEs within each CVSS score, and the dot plot is showing the relationship between the CVSS score and the EPSS score for a particular vulnerability. And below that, we have 3 highest CVSS score vulnerabilities in the past months that are displayed. And when you click on the Learn More button, it'll take you to a more detailed page where it talks about that vulnerability. And now I will pass it on to Catherine to talk about the tables page.
You can see a full screen image of our CVEs table, and I'll walk you through some of the individual elements. So this page is designed to provide a comprehensive overview of all the CVEs we have in our database. First, we display only the CVEs from the vendor selected on the settings page. This ensures that the information is tailored to your specific interests and needs, making the information more relevant and manageable. We've included a pop-up sidebar that appears when you click Filter here. You can filter CVEs by severity, date range, and keywords, allowing you to narrow down to what is most pertinent to you. We've also added a refresh button, so with one click, you can ensure that all the data you're viewing is the most up-to-date. So to further enhance usability, we've implemented an inclusive design. So this means when you hover over different elements, like the colored severity score buttons, helpful captions and explanations appear. Additionally, if there's any unfamiliar vocabulary, hovering over it will provide definitions, ensuring that everyone can use the dashboard effectively, regardless of their technical background. The table is automatically sorted by CVSS score. The users are able to sort by whatever column they choose, either ascending or descending order. Each CVE listed in the table comes with links to the individualized CVE details pages, which Kelly will now talk about.
So moving on to the CV page, this component is a crucial part of our security advisories application, providing detailed information about vulnerabilities identified by their CV IDs. In this component, we leverage the use params hook from React Router to extract the CV ID from the URL. This ID is used to fetch specific vulnerability data from our backend API. Upon mounting, the component makes asynchronous calls to 3 endpoints. First, it retrieves the general vulnerability details as the CV ID, assigner source name, summary, and affected versions. Next, the component fetches the remediation URL and any existing remediation information. In the case whether a remediation URL is available, it provides a direct link for end users to get more details about remediation and affected products. The remediation information can also be edited by the user through an embedded text box interface. To enhance user experience, the component fetches vendor information associated with the vulnerability. This includes the vendor name and logo. Finally, the component includes a circular progress indicator that visualizes the maximum CVSS base score of the vulnerability, providing a quick visual assessment of its severity. Moving on to the About page, it includes a hero image at the top. This image alternates every 4 seconds between 2 visuals. Then scrolling down, we come to the main header, overview of services and tools. Here we explain the core functionality of our dashboard. Next, let's delve into the 2-column section, which provides detailed information about specific features of our system. On the upper left, we have vendor selection, and users can specify particular vendors from whom they wish to receive CVEs. On the upper right, we highlight vulnerability sorting. Users can categorize CVEs based on severity levels, date ranges, search criteria, and vendors. On the bottom left, you'll find CVE detailed information. Here, users can access comprehensive CVE summaries and official vendor advisories, providing in-depth insights into remediation strategies. On the bottom right, we've included Receive CV notifications. This feature ensures that end users receive notifications about security updates, allowing them to promptly address any affected products as well. I'll pass it on to Brian that will talk about the settings page.
This is one part of the settings page, and this is where the users can select the vendors that they wish to track. And on the checkbox shown in the right, these are all the vendors that are currently in our database. And if a user wishes to track one, they can just click on the button and they will start tracking it. But if it's not there, they can enter their company into the Enter Vendor Here button, and it'll add it to our database as well as to the vendors that they're tracking. And we also have an array of vendor logos, and this is just so that the users can have a better experience just using our application so they can have a visual of who they're tracking. And moving on, the settings page also has a profile section where users can select the profile picture from a list of couple. And we also display the username, the email, and the net ID. And these are what we get from the Shibboleth authentication. And we also have a logout feature where it removes the user authentication token that they use to log in, and it will redirect them to the Duke IT website. And now I will pass it on to Ananya to talk about the notification aspect.
So now I'll be talking about the other side of the application, that is sending notifications about security threats. So first we set up an action mailer that connects us to the Duke server and sends the emails through that. We were able to set up our own templates for the emails we send that fetches information about CVEs from the database. We then activated a job that automates the sending of the email without manually triggering the action mailer. As part of the email, we include the CVE number, its description, and its CVSS score for every CVE based on user preferences. Essentially, there are multiple ways through which a user can edit their notification preferences. The first one is vendors, so users can select the vendors that they want to receive notifications about. The next one is frequency. Users can select how frequently they want to receive their emails. It can be weekly, bi-weekly, daily, or monthly. And the last one is criticality. There's a filter to choose CVEs based on their CVSS score. We set up different tables in our database to store the information for these three factors and personalize it for every user. But now I'll be passing it to Catherine to talk about the front end of the security alerts page.
So this is the notification preferences tab, which is included on our settings page. This page is basically designed to give users control over when they receive the CVE alerts. So users are able to set the frequency of emails and also specify the severity and vendors of the CVEs they want. The vendors in this page can be different from the ones selected on the other settings page, as users may have different preferences for what they want to see on the advisories table versus what they want to receive notifications. All of these preferences are saved in our database, as you can see in the three tables in the image below. Our system utilizes these saved preferences via the action mailer that Ananya described. And finally, when a user decides to unsubscribe, hitting the unsubscribe button will reset everything and automatically update the database to reflect these changes. And now Brian will show you our demo so you guys can see our website in action.
You need to authenticate yourself to access the website. This is a homepage where you can see a bar graph with the CVSS score and a dot plot with the relationship between CVSS and EPSS score. These are the top three vulnerabilities in the past months based off the CVSS score.
And this is the table of all the CVs we have in our database. You can navigate between different pages and then sort by each column. And you can also click filter here to filter by severity level, date range, and then also key terms. So say we want to do Microsoft, then all of these CVs have the vendor of Microsoft. And if you click into the link, then you'll find the individual CV details page.
So the details page allows end users to view details of a specific CVE based on the CVE ID. It also has a remediation container with a link that will bring them to the main advisory for the log for the vendor. And then there is an edit feature that permits end users to manually enter remediation information as well. Then in the About page, we can see the core functionality of our dashboard and also the main features that we have displayed in 4 columns so that users can see how to navigate the dashboard as well.
So this is the settings page where users can configure their user preferences. In the profile section, the users will be able to see their username, email, and net ID, as well as configure their profile picture. And then in the vendors page, users will be able to select which vendors they want to track and also be able to delete these vendors, as well as manually add them back.
In this tab, you can edit your security alert preferences. Here, you can select the frequency that you would want. This is the severity that you can choose. And here you can add the vendors. For example, if I add Adobe or if I want to add Microsoft, I can do that. I can also add as many vendors as I want and then delete any vendor. If I see the email, this is an example of the email that is sent, which is basically the CVs from Microsoft and Adobe. And then if you click unsubscribe, that just clears your entire screen.
And finally, there's a logout feature where it locks you out of the page, and if you wish to get back, you need to re-authenticate yourself.
And looking into future development, we would like to incorporate authorization for our application to distinguish between admins and general users so that only admin users have permissions to edit the remediation message for the public to see. We also want to support more data sources beyond CVE details and the Kev catalog. Lastly, currently our front-end application only supports desktop users, so we hope to support more devices such as mobile users in the future.
So we would like to express our gratitude to our sponsors, our team leads, the Code Plus administrators, and the stakeholders who helped us acquire valuable knowledge about security advisories and who were always available to help us and support us during the development process. Thank you so much for listening, and we are ready to accept any questions that you may have.